Okay. Last section, 11.2. Two sample or two population. I don't like saying two sample, but it's typically two samples. What we're trying to do today is figure out, is there a difference between the two means? Or is one mean higher or lower than the other? Okay. So two population means, there seriously is nothing I need to teach you new today. Everything you guys already know. We just got to put some things together, hopefully have a couple of aha moments, hopefully not a whole lot of boring moments, because like, holy cow, I got the conditions, shut up already type stuff. Fair enough with all that? So we'll go through it fairly quickly and then give you guys some time to catch up on your assignments, okay? Monday's review day. Monday's review day and Wednesday's our test day, okay? I want to give you guys the reviews today also. Testing claims about means. So again, we're going to have two different samples leading to two different populations. And what we're trying to do is compare those two populations. We will assume that they're equal, just like we did with two sample proportions. Ho is mu1 equals mu2. Ho is P1 equals P2. And of course, ha is they're less than, greater than, or no different. The first thing I'll jump into is the conditions, because I think we've worn those out enough now that I think we know what these conditions are, except we do have two samples. Well, why are you not changing? Dadgummit. We do have two samples, right? So the conditions are just ever so slightly different. And the fact of, we got to make sure that we have two independent random samples. Two independent random samples. Both samples need to be less than 10% of the population. Guys, I want to make sure, and when I say this, there's not a lot, but to me, 3 or 4 or 5 is a lot. I'm seeing some people just say 10% check. That does not check the 10% condition. You have to say that the sample is less than 10% of the population, okay? And it doesn't take much. I typically just write, come on, n equals whatever it equals, 47, which is less than 10% of all. Something like that. You don't have to write the word population, but just make sure, and it's got to be something like that. 10% check doesn't do it. Less than 10% still doesn't do it. I don't know what you're talking about. 47 is less than 10%. Now you're getting closer. Just finish it out, of all. Make sure that grader knows that you know what you're talking about. Okay, so both of them. And then large samples, and they both have to fit that large counts. They both have to fit the large counts. Hopefully they're both over 30. I need to take this part off because I don't think this ever happens. It's in our book, but I don't think the population is ever normal. Hopefully they're both over 30. If they're not over 30, then you'll have to graph them. And you may have to graph one and the other one be over 30, right? On your test, you will have to graph a set of data to show normality. And when you graph it, you say, oh, thank you. You say, no extreme outliers, no strong skewness. Or no outliers, no strong skewness. Something like that. Aw. Aw. You okay? Both. Click. Hypotheses. This is the way they write it. Mu1 minus mu2 equals, typically that's 0. They'll write mu1 minus mu2 equals 0. If I have to write it, I typically write it as mu1 equals mu2. I think that's easier to understand. It's a little bit less cumbersome. I know that they're equal to it. The book will write it like that, okay? The book will write it like the top one. You can write it either way. And if it confuses you, it's just a simple little rearrangement. It's not your instrument. Yeah. Okay. And of course, the ha, we're less than, we're greater than, or we're not equal to, whichever one we're trying to prove. We're trying to show that this one is less than this one, or it's more than, or they're different. Okay. And whatever this number is, again, typically it's 0, those are the same values. If that's 4, then these have to be 4s. I think it's 0. I don't think I've ever seen it not 0, to be honest with you. I don't think it's not 0. I think they're always 0. But the biggest thing, and one of the things that I took -1 on this last test, is you have got to define mu1 and mu2. Anytime you write a hypothesis, you have got to define that variable. If it's P1, you got to tell me what P1 is. If it's P1 and P2, you got to tell me what they are. If it's mu1 or mu, you got to tell me what it is. If there's 2 of them, you got to tell me what both of them are. You have got to do that, put it in words. And that was a lot of -1s on tests. And I say again, a lot, meaning 15, 20, but it's quite a few. It's not the majority, but there were a lot, okay? You've got to tell me what those are in words. You've got to. Okay, everybody good? Again, I told you guys, the book will write it like this. If I'm going to write it, I'm going to write it like this. It's just easier for me to say, hey, mu1's bigger than mu2, or mu1's less than mu2. It's a little bit harder for me to see that over here. Again, they don't care. Just want to make sure you guys are aware of it. The formula, you guys know the formula. It's in words. It's on your formula sheet. It's your job to change that into variables. For one sample, we know that this was a T. If it's means, it's a T. If it's means, it's a T. If it's proportions, that's a Z. And you just got to know that. Okay, you've got to know that. If it's one sample, your statistic is X bar and your parameter is mu. Well, we don't have one, we have 2. So we don't no longer have a statistic, we have statistics, and it's X bar 1 minus X bar 2. That's our statistic. It's the difference between the two. And then the parameter is mu1 minus mu2. I don't know what just happened right there. Okay? Except, what did we say about our hoe? We said mu1 minus mu2 is, so most of the time that part right there is 0 and we don't have to worry about it. Okay? And then it's over the standard deviation of the statistic. Oh my goodness, the standard deviation of the difference. Well, we never subtract. We always add. And we don't add standard deviations. We have to add the variances. So I have to square S1 and square the square root of n. And I have to square S2. And I have to square the square root of N2. And then I have to take the square root of the whole thing. That's on your formula sheet. You should be able to see that. You should know that. This is multiple choice type questions. They like to change that up to confuse you. How many things differently can I write that? They'll put a subtraction sign right there. They won't square the top. They might square the bottom. Another one I told you guys they like to do is put the DF down there instead of N. They typically don't mess with the top a whole lot. If it's one sample, they like to put the parameter first and the statistic second. So just recognize all that stuff. That's multiple choice questions. That's where they come from. I typically don't write formulas anymore. A lot of you guys don't write formulas. Some of you do. Everybody okay? Y'all kind of know where to get that from your formula sheet if you have to. Click. Oh, here it is, non-hieroglyphics. Except I put a stupid arrow right in the middle of the way. Click. Your DF, you're going to get it from technology. It's that really big formula that's nasty. You're going to get it from technology. Just punch it in your calculator or punch it in Desmos, and when you hit enter, it's going to give you that DF. And just put that DF down. Just put it down, whatever it is. Or if you're going to use the, what was it? Can't think of the word. I don't know, the safety approach. Not safety. Who cares? Use the smaller of the n-1s, but you're never going to use it. You're going to use the one in the calculator. Don't use the smaller one. Your book might do it every one. Don't use the smaller one. Don't use the smaller one. Use the one that the book get or the calculator gives you. Click, click, click. Okay, here we go. Here we go. Has the mean number of hours Americans work week changed? Mean. It's not going to be really confusing as it means or proportions. They'll say proportions in there somewhere. They'll say means in there somewhere. They'll give you an X bar or they'll give you decimal. One of the questions from the GSS asked responders how many hours of work they work, how many hours a week they work. Responses from random samples of employee Americans were recorded in 1975 and 2014. And here's their summary. So here's 1975, here's 2014, here's the sample size, 764 and 1501. Hours, standard deviations. State the appropriate hypotheses. Make sure you define the parameter. Ho, mu 5 equals mu 4. I put 5 for 1975 and I put 4 for 2014. If you still want to use 1 and 2, use 1 and 2. If you want to use 6 and 7, ha. Mu 1, or I'm sorry, mu 5, mu 4, significant level of difference, not equal to. Not equal to, and then I got to define it. Mu 5 is the true mean hours worked per week 1975. Whew. I got to write all that? No, you don't have to. I can take off 1 just as easy. I'm either going to write a check mark or -1. You want check marks and write it. If you don't want check mark, don't write it. Easy. I don't know how to say it. Got to say mu 4. And then I'm just going to put a bunch of quotes because it's the same stupid thing until I put 2014. And AP's perfectly fine with that. I know you can't see a whole lot. I'm sorry. I'm doing an experiment with these tables. I don't know how well it's working, but that's all right. Yes, no, maybe? Pretty easy, yes? I hope. Here it is, non-hieroglyphics. I wrote it a different way. And they put sub 2014, and they put sub 1975, and they actually put the 2014 first. And who cares? That's why we define everything and do everything. Beautiful. Check the conditions. 2 independent SRSs. 764 from 1975 and 1501 from 2014. Beautiful. There's one of them. There's one of them. 764 is less than 10% of all workers in 1975. 1975. 1501 is less than 10% of all workers 2014. One, two, three. SRS, random, 10%, large counts. Oh, this one's the easiest of all of them. 764 is greater than 30. 1501 is greater than 30. Check. About the easiest one we can do. We don't have to do n times p. We don't have to do n times p hat. We don't have to graph anything. We're way over 30. 1, 2, 3. 1, 2, 3 points. E, P, or I on the AP exam. Conditions get their own E, P, or I. Beautiful. Here it is, non-hieroglyphics. Independent random samples of 764 working Americans in 1975, 1501 working Americans in 2014. Do I have to put all that? I think we've discussed that. No. We don't want SRS. Check. That's what we don't want. 764 is less than 10% of all working Americans in 1975. 1501 is less than 10% of all working Americans in 2014. Do I have to put all that? No. Gotta get close. 764 greater than 30. 1501 greater than 30. Do I have to put all that? Yeah. I don't know how to shorten that up. Y'all good? Questions? Conditions. They are brutally important. The only time you don't have to check conditions is if it says the conditions have been met. If it says conditions have been met, you don't have to check it. Boop. Calculate the standardized test statistic and the p-value. X bar 5 equals 38.97. S sub 5 equals 13.13. N sub 5 equals 764. X bar sub 4. $41.91. S sub 4. 14.35. I'm way at the back of you now. N sub 4. 1501. DF equals T equals P value equals, and now I'm going to let TI do it. Do I have to put all that? No. You can write the formula and put the values in, or you can do that. So yes, you have to do all that, or write the formula and put the values in it. So here we go with our little calculator. Just to make sure you guys can do all this stuff, exit the screen, calculator, because I sure don't want the calculator to be the issue. Stat, test, z-test we don't use for anything. T-test, that's what we did Wednesday. That's one sample T-test. 2 sample Z, we don't use that for anything. And there's 2 sample T. 1 prop Z is right underneath it. That's what we did in 8.1. No, I'm sorry, that was 9.10. Yeah, 9.2. 1 prop Z, 2 prop Z, and then we did the intervals. We don't use Z for anything. So you're just going to hit enter, and you either have one of two things. You have the statistics or you have the data. We have the statistics. And so all you got to do is put in that X bar 1. Luckily, I already have it in there. And you got to put in the standard deviation of 1, and luckily I got that. And there's N1. And here's X bar 2. And there's S of X2. And there's N2. And then there's my alternative. I think it was not equals to, I'm assuming. Not equals to. Pooled, always say no. Always say no. Always say no. Calculate. Boom. There's your T. There's your p-value. There's your DF. And there's X bar 1, X bar 2, standard deviation 1, standard deviation 2, and N1 and N2. Just put it all on your paper. Put it all on your paper. That's all you need for calculations. Okay, I'm going to beg you guys. Everybody's here but 2 people. Please, for the love of goodness, please do not put down the p-value as 1.15. If you put the p-value as 1.15, we're not doing very good in this class. Because the p-value, the chances of getting the sample we got, and I don't think the chances we get is 115%. Good? There's that times 10 to the -6 way over there. And if that confuses you, just put the p-value is really, really small. Or the p-value is almost 0. You can put that, that's fine. If you can understand it, you can put the p-value as 1.15 times 10 to the -6. But please don't put 1.16. Okay? Please don't do that. It really makes you not look intelligent. It looks like you have no idea what you're doing in this class. Fair enough with all that, right? So please don't do it. Luckily, it's only -1 on the test, but it should be minus like 200. Luckily, the students that have done that previously have said, since the p-value is so large, I will fail to reject. Well, I'm glad. They still got 115%. It's really crazy when it's 4.6. 460% chance. No. Everybody okay with that? Good? Just understand what, and Desmos will do it too. Oh, I'll just use Desmos. Okay, they'll do the same thing. I think they actually show the times 10. Okay, just be careful of that, please. Please, please, please. But put all that stuff down. Just put it all down, and that's going to be enough for your work, and that's enough for your everything else. Okay. You can write the formula if you want to. You can write the formula if you want to. That's what they did. They wrote the formula, plugged all the values in, and got that 4.88. Now, theirs was positive 4.88. We got negative because they flipped off everything. Doesn't matter. It's a two-tailed test. They still got the DF of 1660.58, and they got the p-value, and they put 0.000000115. And again, they're okay with you saying the p-value is really, really small. The p-value is almost 0. It's okay. You're a whole lot better saying that than 1.15. If you use the conservative, that was the word I was looking for, conservative of 100, then you're going to get a completely different p-value. But use the calculator and you don't have to worry about it. Don't say DF is 100 and get this number. They'll get you for that because those don't match. Those don't match. Everybody okay with that? Good? Last thing, what's the conclusion do we make? Well, with a p-value that low, that hole got to go. Got to reject. Got to reject. There is enough evidence to say there is a difference in the average number of work hours from 1975 to 2014. Don't say there's more hours worked. We didn't do a right tail test. Don't say there's enough evidence to say we work more now or more 2014 worked more. No, you can't say that. You didn't do a right tail test, you did a two tail test. So all you can say is it's different. Because the p-value is less than alpha, we reject. There is convincing evidence of a difference in the true mean hours worked by Americans in 1975 and 2014. What do you think? Yes, no, maybe? Easy peasy, lemon squeezy. Man, I hope so. Whew. Telling y'all, this should be one of the easiest tests you guys have taken all year. And I'm not making that up. Free response anyway. I don't know about the multiple choice. Multiple choice might be tough because it's got 4 sections in there, but click. Another example. I don't want to go through the entire thing. I just want to read it. Have you guys read it with me just so you guys can see another example. Does increasing the amount of calcium in our diet reduce blood pressure? An examination of a large sample of people revealed a relationship between calcium intake and blood pressure. There's a relationship. Such observational studies do not establish causation. Wow, they're starting to bring up some stuff from chapter 4. They didn't have to tell you that because you guys already know that. Researchers therefore designed a randomized comparative experiment. Ding, 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 ding. That already tells me that I'm not going to check the 10% rule. I'm not going to check it because this is an experiment. Okay? Randomized. The subjects were 21 healthy men who volunteered. Ding, 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 ding. This is not an SRS. Don't say it's an SRS because it's not. Volunteered to take part in an experiment. They were randomly assigned to 2 groups. 10 of them received a calcium. The control group received a placebo of 11. The experiment was double blind. Oh, what does that mean? They don't know which one they're taking, and the guys don't know which one they're taking. The response variable is the decrease in the systolic blood pressure for a subject after 12 weeks. An increase appears as a negative number. So there's the data, here's the data. Does the data provide convincing evidence? There's the big question. That's the one you guys are going to see next Wednesday. Convincing evidence. That means we got to do MCCC. We got to write the method. We got to do the calculations. We got to do the conclusions, and we got to do the conditions. And you can do them in any order. I said them backwards, and who cares? You just got to get them all in there. This is not greater than 30, so I'm going to have to put these bad boys in L1, and I'm going to have to put these bad boys in L2, and we're going to have to graph them both. And that might be harder for you guys to do than actually knowing what to do. Let's just make sure. I'm not going to put them all in there, but you got your calculator, right? You got stat edit. So put one of them in L1 and put one of them in L2. And if you want that data, then put it in L4 and L5, or you can put it in L6 and L3. Who cares? Just get it in there, right? Hit second and Y equals to turn that graph on. Turn one of them on here and turn the second one on here. And put one of them as L1 and the other one as L2. Or if you put it in L6 and L2 or L1 or wherever you put it. Zoom 9. Boom, boom. That's the graph, both the data. This is not that data. This is the battery hours, and that's the DO level in the river. But you'll see them both. Sketch them on your paper, and we'll say what? No strong outliers, or no strong skewness and no outliers. And then when we go to stat tests, whoops, get over there, and we do the 2 sample T test, this is the time where we'll go over here and say data. Turn it on. L1, L2. Frequency's 1. Frequency's 1. Whoops, got too close. Stat. Test. Whoops, still didn't do it. Stat. Test. That's number 4. There we go. L1, L2. Pooled, no. Calculate. And when you go down to calculate, that's what gives you all that information. There, I don't remember if this was not equal. I didn't do the ho and the ha yet. Oh, it wasn't a double-tailed. This was a left-tailed or a right-tailed, depends on which way you put it. Because we're trying to prove that the calcium reduces it. Anyway, there's your T, there's your p-value, there's DF, there's X bar 1, there's X bar 2, there's standard deviation 1, it gives you everything you need. Just put it all in your paper. Do I have to put it all? Yeah. Yeah. Put it all. Do I have to? No. Okay, good. I can put -1 just as easy as I can put a check mark. Put it all. Put it all. Click. Click. Slideshow. There's ho and ha. Mu C minus mu P is equal to 0. Mu C minus mu P is greater than 0. I would have mu C equals mu P, and I would have mu C is greater than mu P. What do we want? The calcium reduces? So that'd be one you may want to put the greater than or less than after you did the test. Do the test. If you did less than and you got a p-value bigger than 0.5, switch it. Switch it. Because there's no way it's bigger than 0.5. Define mu, define mu. 2, SAMP-T test. There's your method. I count the method as 2 points. I count it as 2 points. If you put down the method and don't put anything else, you're going to get 2 points. Random. The 21 subjects were randomly assigned. Approx normal. They did dot plots. You're going to do box and whiskers. But you can do a box if you want, or dot if you want to, or you can do a histogram. 10% is not needed. Do I have to write that? No, you actually don't. What if I do? I hope you write not needed. Don't put 10% check. Bless you. Click. There's X bar. Here's XS. Here's N. There's X bar. Here's S. There's N. They wrote the whole formula right here. You don't have to do that, but you got to tell me what the T value is. 1.604. DF is 15.59. That gives me a P value of 0.06. Because the p-value is 0.06 and I use 0.05, I'm going to say, since the p-value is greater, fail to reject. We don't have enough evidence to suggest that calcium supplement reduces blood pressure more than a placebo on an average for subjects like the ones in this study. I'm going to answer it just like they asked it. That way I really don't have to think that much about it. I can remember it was subjects like this. Yes, no, maybe. Clicky, click, 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 click. Greater than. The experiment does not provide convincing evidence that the true mean decrease in systolic blood pressure is higher for men like those who take calcium than for men like these who take a placebo. Click. Interpret the p-value. Don't forget that. The p-value is the chances of getting the test statistic, the chances of getting the difference we got. I think that's the only 2 ways I can go about it. Or greater, or less for this one. I think this one was or greater. Assuming ho is true. You got to put all that in there. Got to put all that in there. Click. Assuming HO is true. There's a 0.0644 probability of getting a difference of mean blood pressure in the two groups of 5.273 or greater. Man, you got to know that. I don't think last test I actually had it on there. It's on one of these. I don't remember which one. I know I'm going a little quick, but I think we've repeated this so much. Click. Here it is on the calculator. Beautiful. Beautiful. Just in case. Always say no on pooled. Just say no on pooled. I don't want pooled means you're pooling the data together, and we're not pooling the data together. We did for proportions. That's why we had p hat sub c. We pooled it together. It means we don't pool it together. Paired. This one's the one that's going to get you. To me, this is one of the hardest things to catch. Paired data versus two sample data. Okay, I think this is one of the harder ones to catch. Paired compared to two sample. Okay. The biggest thing is it's not independent. And when you do your conditions, just talk about it being paired. Talk about it being paired. The paired data came from an SRS. The paired data was randomly assigned. Paired data. The difference in the pairs are less than 10% of all pairs. The differences are greater than 30. Or the graph of the differences shows no strong skewness or outliers. You just got to start talking about the differences. Okay? What if I mess up? If you mess up confidently. Like do the whole thing through like you would. Because you're going to get dinged a little bit, but not near what you get dinged by just leaving it, by flip-flopping or doing this, whatever, going rogue. If you decide it's paired data, do it paired data. And paired data, guys, it works just like we did on Wednesday. Paired data does exactly what we did on Wednesday because it becomes one sample. It becomes one sample. And one sample, we already know how to do because we did that on Wednesday. Just talk about things being paired. Things being paired. We're going to do a paired T test. The pair was randomly selected. The pair of them is less than 10% of all of them. The graph of the pairs or the graph of the differences. Okay? It's one sample. It's one sample. So mu equals whatever. Most of the time that's 0. Most of the time it's 0. They'll put sub D. You don't have to. I think it's good to, but you don't have to. You don't have to. And of course, ha is greater than, less than, or not equal to. There was a question, it's several years ago now. What they did is they got the typing of groups per minute on a group. Their typing speed. And then they put them through a course. And then they did their typing speed again. So you got two measurements on a same individual. That's paired data. And the claim was that that typing speed will increase their GPMs by 3. So that one would be 3, not 0. And we thought that that was too much. We didn't think it would improve it by 3. So ha would be less than 3. Okay? But it should be pretty obvious what this number is. Like I said, it's just what we did on Wednesday. It's one sample. One sample. The formula is one sample. T x bar minus mu standard deviation over the square root of n. It's one sample. It's one sample. They will put sub D's down. You can. You don't have to. They might put sub DIFF down. Whatever. Whatever. It's just one sample. It's what we did on Wednesday. And because it's one sample, the DF is n minus 1. It's back to our easy one. N minus 1 for our DF. Good? Yay? Questions? Click. Let me read you one. Researchers designed an experiment. Experiment. To study the effects of caffeine withdrawal. They recruited 11 volunteers who were diagnosed as being caffeine dependent to serve as subjects. Each subject was barred from coffee, colas, and other substances with caffeine for the duration of the experiment. During one 2-day period, subjects took capsules containing their normal caffeine intake. During another 2-day period, they took a placebo. The order was randomized. At the end of the 2-day period, a test for depression was given to all 11 subjects. Researchers wanted to know if being deprived of caffeine will increase depression. Here's the table of data. We are getting 2 measurements from one individual. That is paired data. That is paired data. You are getting 2 measurements from one individual, and so your job is just to subtract those numbers. Subtract them. And that's what we did Wednesday. Use that data. Don't use the depression of caffeine, and don't use the depression of the placebo. Use the data of the differences. Okay? This is what we're going to call the mean, difference. That's the mean difference, not the difference of the means. There's only one mean. There's a bunch of differences. There's only one mean. There's a bunch of differences. The question we did earlier, there were 2 means, and we did 1 difference. That's the difference of the means. So you make sure you got to say it right. I don't know, who thought this was an English class? Mu sub D equals 0. Mu sub D is greater than 0. Mu sub D is a true mean difference. There it is, mean difference in the depression test score for subjects like these. Okay? Paired t-test. That's what you're going to call it, paired t-test. Researchers randomly assign the researcher the placebo and then a caffeine pill. The sample size is small, but the graph shows no strong skewness or outliers. Yada, 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 yada. This is posted. You guys can come back to it. Here's X bar sub D. Here's S sub D, and here's N. There's DF. There's the p-value. Oh, where? Right here. P-value. P's low, the ho's got to go. We're going to reject this. There is enough evidence to suggest the true difference is greater than 0. Clicky, click, click. What's the yes, no, maybe? There'll be some questions that will help you out tonight about is this paired data or not paired data. Okay? Let me give you a couple. Let me give you a couple right now. Each of the following settings decide whether you should use a 2-sample T procedures about the difference in means, or paired T, which is the mean difference. Again, that's the language, you guys. That's tough. Uh-oh, that circled the wrong thing. Difference in means, plural means, or the mean difference. One mean. I like to say the mean of the differences. That helps me. Okay, before exiting the water, scuba divers remove their fins. A maker of scuba equipment advertises a new style of fins that's supposed to be faster to remove. Consumer advocacy group suspects that the time to remove the new fins might be different, no different than the time required to remove the old fins. So here's what they did. They took 20 experienced scuba divers. They're recruited to test the new fins. Each diver flips a coin to determine if they wear the new fin on the left and the old fin on the right, or vice versa. The time to remove each type of fin is recorded. Paired data, 2 independent random samples. 2 pieces of data from 1 person, or 2 completely independent random samples. Y'all okay? This one's by far paired data. Okay, this one's by far paired. Could I do 2 different? Yeah. Yeah, we had 20 experienced scuba divers. We randomly assigned 10 of them to use the new and the other 10 to use the old. I don't think that's as good. This one's paired. To study the health of aquatic life, scientists gather a random sample of 60 white piranha fish during 1 year. The average length of these fish was compared to a random sample of 82 white piranha from the same tributary a decade ago. Do we have 2 independent random samples? Or are we getting 2 measurements from 1 thing? Are we doing a before and after? I think that's 2 independent random samples. In fact, this is a random of 60 and 82. I don't know how you compare 60 and 82. I don't think you compare 60 and 82. I think you got to compare X bar 1 to X bar 2. Okay? Last one. This one's a little tougher. Can a wetsuit deter shark attacks? Researchers have designed a new wetsuit with color variations that are suspected to deter shark attacks. To test this idea, this is scary, she fills 2 identical drums with bait. Luckily, we didn't use people. Covers one in a standard black neoprene wetsuit and the other with a new wetsuit. Over a period of 1 week, she selects 16 2-hour time periods, randomly assigns 8 of them to the new, the old, and the other 8 are assigned to the new. During each time period, the appropriate drum is submerged in waters. The shark's frequent and number of times shark bites the drum is recorded. 2 measurements from 1 thing, or 2 independent random samples. That one's 2 samples. Okay? That one's 2 samples. We didn't pair it up any way possible to begin with. And how you pair them up, I don't really know, other than maybe you pair the barrels up and throw them in at the same time and see if one gets attacked and the other. I don't know. They would mention it. Guys, I hope this is an easy exam for you guys on Wednesday. So I hope you can state the appropriate hypotheses for a significance test. I hope that you can determine whether the conditions are met. If we can't do that by now, boy, we are in deep boo. Calculate the standardized test statistic and the p-value. I hope you can perform the significance test about the difference between 2 means, and I hope you can perform a significance test about the mean difference. And I hope you can determine when it's appropriate to use paired versus 2 samples. I got to hit this button, and I got to hit this button first, and then this button, and then this button, and I think I forgot to assign it